Hello everyone, my name is Yasmine Adla, and today I'll be presenting our paper titled Design and Comparison of Arabic Negotiation Bots Using Large Language Models versus Sequence-to-Sequence Models with Reinforcement Learning. The outline of our presentation is as follows. We start with an introduction, related work, proposed methods for large language models and sequence-to-sequence models, the experiments and the evaluation of our work, conclusion and future work. So starting with an introduction, over the past several decades, negotiation has proved itself as a vital skill in various settings, whether it's personal, organizational, or governmental. And with the rise of AI, it was seen that AI bots had an opportunity for advanced negotiation. However, as seen in the literature, progress in Arabic bots was limited. Therefore, the aim of our work was to develop Arabic negotiation bots. Okay, so in this research paper, we worked on a certain negotiation scenario where we had a buyer, Amani, and the seller, Samir, where they had a set of items, books, hats, and balls, and they wanted to split these items between of them. However, each agent had a certain value. Each agent had a certain assigned value with respect to each item, and they'd had to split them in a way that optimized the value for each agent with a certain predefined set of rules until a certain outcome is reached, whether it was a deal or no deal. Therefore, the contribution of our paper is as follows. We first present the first Arabic negotiation bots using two distinct approaches. The first is a pre-trained LLM with zero-shot prompting and a sequence-to-sequence model with reinforcement learning known as RNN-RL, which was inspired by Meta's deal or no deal framework. And we proposed two new datasets, one for the large language model and the second for the RNN-RL model. So a bit of overview of the related work, given that no Arabic work has been existent in the literature when it comes to negotiation bots. We have early methods such as game theory and rule-based methods, which really depend on a set of predefined rules and if-else conditions. Heuristic approaches, which also depend on heavily predefined rules. Deep learning approaches, which Meta has really shaped since 2017. It added emotion, persuasion, and politeness to the aspect of negotiation. And finally, we have transformer-based models such as, these very popular now transformer-based models. We're talking about GPT, Claude, BERT, and much more. Okay, so let's start with the proposed method, the LLM. So basically, the goal here was to let a certain LLM, a pre-trained LLM, in our case, we worked with the GPT 3.5 Turbo, let it go into self-play mode and negotiate and simulate a realistic negotiation dialogue where the LLM generates in Arabic offers, counter-offers, justifications. So we'd start with this pre-trained GPT 3.5 model and employ zero-shot prompting to negotiate in negotiations. So here we have example of the prompts used. We'd have certain prompts, of course, in Arabic to let the model engage into self-play mode and assume both the role of the buyer and the seller and to split these items between both of them. We'd also sometimes prompt the LLM to try to negotiate on the price, sometimes from a buyer stand view and sometimes from a seller stand view. So we'd have both buyer and seller negotiation strategies. Here are some illustrations of LLM prompts that were used to split the items, such as go into self-play negotiation mode. During the game, Amani and Samir, which are the buyer and seller, collaborate to decide how to split the items, take turns to do so and so, exchange, simulate both roles, etc. The second approach was the RNN-RL approach. So basically, In order to do that, we took the dataset, which was based on Meta's English negotiation dataset in 2017, which contained human-to-human negotiation dialogues collected through Amazon's Mechanical Turk. This dataset was basically taken and translated into Arabic using Google Translate, and some additional validation was done to ensure that the dataset was up to par to the Arabic language. It basically contained 5,800 dialogues derived from approximately 2K unique scenarios. And then we split the data into 80% training, 10% validation, and 10% testing. So in this case, we then trained a sequence-to-sequence model, which was based on gated recurrent unit components, GRUs. The RNN component first takes one agent dialogue and produces another agent response. That's why we have 3 GRUs: the GRUG, which encodes the goals; the W, which generates responses based on previous tokens and goals; and the GRU0, which basically makes final decisions using bidirectional mechanism and attention. So after basically the RNN-RL takes these structure inputs and is trained on the history, the item values, and the agent preferences, we're able to optimize the outcome using reinforcement learning, where of course we have a reward function and an optimization goal that we want to reach. So moving to the experiments conducted, in order to evaluate the large language model, how well it did, we had certain key metrics that we defined. So coherence, which shows how logical progression and structure of the negotiation dialogue goes. Complexity in terms of depth of vocabulary, sentence structure, and negotiation tactics. Of course, here we're talking about the Arabic language. Language quality, grammar accuracy, vocabulary, how appropriate was the vocabulary, and fluency. Style, which is how appropriate the tone and the persuasive language was, and negotiation dynamics in terms of strategies. We recruited 5 human evaluators that were proficient in the Arabic language and told them to rate each dialogue from a scale to 1 to 5 for each metric. Okay. As for the RNN-RL result, we used intrinsic properties such as cross entropy and perplexity, which basically, in the case of perplexity, it measures the model's ability to predict the next word. The lower, the better. And when comparing our work to the English language, there was a significant decrease in performance for the Arabic RNN-RL, where in the English language it had a very high perplexity, but in the Arabic language we even got a higher one. The poor performance might be attributed to the complexity of the Arabic language and the smaller data set available for training. As for human evaluation, here we have the results between the LLM output and the RNN-RL output. So we can see that the LLM was significantly better on all different metrics. We have an average of 4 approximately across all. The RNN-RL performed way worse, where it was seen that the LLM had a much more human-like and coherent approach when it comes to negotiation, whereas the RNN-RL struggled with the complexity of the negotiation dynamics. So when it comes to the effect of LLM negotiation strategies, when we asked the LLM to include buyer or seller strategies, we can see that for the buyer, the final average price when we had buyer tactics, we were able to decrease the price from like $17 to $15. However, for the seller, we had mixed results due to maybe some data imbalances and the more complex role of the seller in negotiation. So here the LLM actually had difficulty following instructions in Arabic. So if we want to compare both side to side, LLM was way richer and had more expressive interactions. However, the RNN was more quicker to reach resolutions. The LLM was creative, but had some mistakes where it would incorrectly allocate item quantities. This will be seen later in my paper and a later paper as well that I'll be talking about. And the LLM did experience some hallucination, which Professor Gerard already talked about, where it suggested splitting items that were physically indivisible, such as splitting a ball in half to maintain fairness in negotiation. However, the LLM does have a edge here where it's easier to train given the zero-shot prompting approach versus the need of a data set in the RNN-RL approach. So as a conclusion, to wrap things up, we present in this paper the first Arabic negotiation bots with two different approaches, one based on large language models, the other one based on recurrent neural networks with reinforcement learning. LLM showed a more promise with minimal data overhead. However, as future work, we'd have to really address hallucinations and context-specific responses, and maybe try to initiate negotiations without the need of constant reminders. So this work was done, was made possible by a grant from Qatar National Foundation. And thank you so much for your time. If you have any questions, I'm open.